Good day, ladies and gentlemen. I hope you're all in good health and good spirits, especially during these challenging times. Today we're going to learn about a very interesting topic, force. So what does force actually mean? Well, there are different ways to describe it really, but there are two main ways that I'm going to focus on here. The first is the simple and intuitive way, which is that a force is a simple push or a pull. So you push something, for example, you may push against the wall, you're applying a force. You pull something, maybe you're pulling a trailer, that's a force. So it's basically a push or a pull vector. Now there's also the more complex, I think a better word would be the more precise way to define what a force is, and that would be that the force is an influence which tends to cause an acceleration. Whether or not this force causes an acceleration depends on whether or not the force is opposed. For example, let's say you're pushing against the wall. You don't cause an acceleration because the wall's normal contact force and its friction with the ground prevents you from doing so. Those forces oppose you. But if a force is unopposed, it is unobstructed, the force will cause an acceleration, which may mean that it changes the velocity, or the magnitude, or the direction of the velocity. Let's consider some examples. The first would be you lifting a mass, and I'm going to leave it up to you to guess what the name of the force is. The second would be a car, where the engine applies a torque to the wheels, and this torque causes the wheels to rotate, and then they in turn exert a frictional force with the ground, and this frictional force is what really causes you to move. With regards to the sun exerts a certain type of force on the earth, and let's see if you can remember what this is. So the person lifting up the mass is basically weight, he's applying a weight. The torque is the turning force of the wheel, and the friction is the force between the ground, and then the sun exerts a gravitational force on the earth, causing it to rotate around the sun. And it's also useful to know what the symbols for these forces are, which are on the screen right now. Now we're going to discuss the types of force, and the first force we're going to look at is the gravitational force. The gravitational force acts whenever there are two masses and is separated by a distance. It's given by the symbol Fg, and the formula is Fg equals g times the mass of the first object times the mass of the second object over the square of the distance between them. G is a constant known as the universal gravitational constant, and the reason it's called universal is because it's not like other constants which may change. This is actually a fundamental constant, and the value of G is always the same, 6.67 times 10 to the minus 11. Now, again, I'm just going to annotate the figures so we know what the variables mean. Now let's look at the electric force, which acts on charges, very similar to the gravitational force. There are two charges separated by a distance, we'll call that R. The two charges have to be opposite in nature to attract, otherwise the force will be the same, but they're going to repel. So we have a positive and we have a negative charge. And the charges are big Q and small q. So the electric force will be given by Q times big Q times a constant K over the square of the distance. And this constant K is given by the expression 1 over 4 pi epsilon naught, where epsilon naught is the permittivity of free space. This tells us how easily, or in this case, how hard it is for space to form an electric field. It's the resistance of space to form an electric field, and the value is on the screen. It's actually 10 to the minus 12, and I'll correct that in a minute. K has a rough value when you calculate it of 8.99, or roughly 9 times 10 to the power 9. Now we'll look at the next force, which is the frictional force, which acts between two surfaces, especially when there's motion involved. Now the surfaces should not be smooth, they should be rough surfaces. In smooth surfaces, there's no friction. In perfectly smooth surfaces. So we'll assume there's a cube-shaped object, or in this case a square, because I'm too bad at drawing cubes, and you apply a force. Well, the object may not move, and that's because of friction. And it's the same force, which is why when you throw something in the air, it slows down, assuming it doesn't land on the ground before that. Same with a bicycle. If you're riding a bicycle, you may notice that the moment you start pedaling, the bicycle starts to come to a rest. It slows down and the velocity goes down. And that's because of the frictional force, not just due to between the wheels and the ground, but also between the bicycle and the air. Because remember, air particles can also have a frictional effect. Friction is given by mu times n. Mu is the constant known as the coefficient of friction, and n is the normal force or the contact force between the surfaces, the force with which the two surfaces are pressed together. There are two types of friction. There's static friction, which occurs when an object is at rest, and there's kinetic friction, which is the friction you experience when you're moving the object. Usually static friction is greater than kinetic friction. Then comes tension. Assume you have an object with a rope connected to it and you pull on the object with a force. The object moves with a velocity, and all along this rope there is tension. Now tension, what really is it? Well, tension is a force which acts along strings, wires, cables, springs, and that sort of thing. And it acts all the way along the length of the string of the rope. Tension has no real formula because tension is basically the force you apply. For example, let's say you have a round mass. The force that it exerts is the weight, which is mg, where g is the gravitational constant. Then the tension on the rope will basically be equal to the weight of the object. And consider that the string is connected to a surface. Well, then there'll be a tension acting from the point of connection. Remember, tension always acts away from surfaces and towards the center of the string. So, what can forces really do? There's a couple of things. First, as we saw, forces can cause acceleration. They can change both the magnitude and the direction of a velocity. Some forces will increase, while some forces will decrease the magnitude of the velocity, and the initial velocity doesn't have to be at the origin. Now, most people write F equals ma, but I like the expression A equals F by m, because F is an independent variable and A is a dependent variable which depends on the force. But you can use whichever one you like. Forces can also change the shape or the structure of a material. An example would be atoms regularly arranged. When you apply a force, that causes an acceleration between the atoms, and that causes the shape to change. When you cut something, you cut a cake, for example, the structure changes. Let's say you have a piece of Play-Doh and you drop a mass on it. Well, then the Play-Doh will become flattened and soft, and that is changing the structure of the object. The next video will cover more complex types of forces. For now, thank you very much for watching and for supporting this channel. I hope you learned something and have an excellent day.